Example 4, Tech Active. In 1950, Rockhampton was the second largest city in Queensland with a population of 40,000 people. So that's first piece of information. In the year 2000, the population was 60,000, assuming that the rate of growth of the population was constant. A, develop a relevant mathematical model for P in terms of the number of years T. B, use your model to calculate the theoretical population in 2020. Now, this is Tech Active, but I am going to algebraically determine the model first and do the same for part B. I will have to use a calculator in part B. I'm then going to show how to do part A with technology. Very similar to what was done in the very first example. But that way I'm covering both an algebraic model and technology, which can be used to verify your model. This will help you with the homework as well. So first of all, it says that P is population, T is time in years. The rate of growth of the population was constant. So dP dt is proportional to P. That's what that means. dP dt equals Kp, and that means we can use that exponential growth model. Okay, from there, the information in the question to help us find this model. In 1950, Rockhampton was the second largest city with a population of 40,000 people. I am going to assume 1950 is the initial population. So that means 1950 T equals 0. Our population is 40,000. And that is our P0. So P equals 40,000 E to the KT. Now, I could have substituted T as 0. So I could have gone 40,000 equals initial times E to the K times 0. 40,000 equals initial P, E to the 0. 40,000 is my initial value. Don't always assume that T is 0, the value given to you is initial. If you had a constant added to your model, that would not be the case. So be very careful, don't just assume. Now I need to find K. That's going to be used with that green bit of information in 2000. So the year 2000, if 1950 is initial, that means T is 50 for 2000. My population is 60,000. So 60,000 equals 40,000 E to the 50K. Divide both sides by 40,000. That means I have 3 over 2 equals E to the 50K. Go to a log. 50K is ln of 3 over 2. K is 1 over 50. ln of 3 over 2. Coming up. So for part A, my model is population is 40,000. E to the 1 over 50 ln of 3 over 2 T. Keep watching the video because I will go through how to find that using technology. Part B, use your model to calculate the theoretical population in 2020. So 2020 is another 20 years, so T is going to be 70. So my population is 40,000. E to the 1 over 50 ln 3 over 2 times by 70. So putting that in your calculator, you get that P is approximately 70,000 564.74. We are talking about people, so you would want to round. Now, you could round up, you could round down. It's not a huge deal. I personally round down because we haven't got that 65 yet, and therefore with our therefore statement. Now let's go to our calculator and solve it fully using technology. So my recommendation for solving this problem using technology would be to regress, so using the spreadsheeting function. T is in my first column, initial, and then we have 50. Population. So initially 1950, we had 40,000 people. And then in 2000, 50 years later, we had 60,000 people. Different cell, menu, statistics, stat calculations, exponential regression. T in the first column, P in the second. Now you'll note that that puts it in the form of A times B to the T. So 40,000 multiplied by 1.01 to the power of T. So I've screenshot what I got from the spreadsheet. So my model is P equals 40,000 multiplied by 1.01 to the power of T. And yes, our R squared is 1, but that's because we only had 2 coordinates. Now, these are 2 different forms of an exponential model, one in the form of B to the T, one with the E to the KT. So to verify, we're going to have to compare these 2 values. Now, if you're in an exam, knowing 2 methods of solving is really important because it helps you check whether you've made a mistake or not. And trust me, it's really easy to make silly mistakes. So if I go to my calculator and determine what e to the 1 over 50 ln of 3 over 2 is, I get approximately 1.008 or 1.01. So fantastic. I know I haven't made a mistake. Now, these models are different. If you needed it in that E form, you would have to go, well, E to the power of some unknown value, whatever constant variable you want to use. If I go e to the m, we need that to be 1.01. So m is ln of 1.01, which is approximately 0.01. So I could write the formula in the form of P equals 40,000 e to the 0.01 t. Moving on to part B, we're going to go back to our calculators. So going back to our spreadsheet, we want to be able to graph this. So we go document, insert, page, not problem. We want to use that equation, add graphs. If you move up, you can see that equation. So press enter. There's no graph because our window is not big enough. So zoom fit. We now have that graph there. T is greater than 0. Move that equation out of the way. I want to use my model to calculate the theoretical population in 2020. So T is 70, menu, trace, graph trace. T is 70, and our population is at the bottom. So 70,564.7, which is what we previously found.